Okay guys, Assalamualaikum and salam sejahtera. Now let's have a move on tutorial 1.8. Okay, so this tutorial question is based on the Chapman's book example 1.8. So let me read the question first. The figure shows a conductor moving with a velocity of 5 meters per second to the right in the presence of magnetic field. The flux density is 0.5 Tesla into the page and the wire is 1 meter length, oriented as shown in the figure. So this is the figure that we are going to consider. What are the magnitude and polarity of the resulting induced voltage? Meaning that we want to find the magnitude and polarity of the induced voltage. So we know that when we move this wire in the magnetic field to any direction, like say for this one to the right direction, what happens is the voltage will be induced across this wire, right? So let's have a look at this canvas. Okay, so we have the wire here, and then there is no current inside this wire. It's actually just a blank wire. We just take the wire and move it in the magnetic field with velocity of v. So we move it with velocity of v in B, in the magnetic field. What happens is the voltage will be induced. The question is, how do we know the direction and polarity? I mean, the induced voltage direction. So to know the direction of the induced voltage, we can use the left hand rule. Which is our thumb represents the velocity, our middle finger represents B. So in this case, B is to the directed into the page. So our index finger shows the direction of induced voltage. So meaning that the induced voltage, we can draw the induced voltage in this case is from bottom to upward. And then also we can just put some positive and negative notations for that induced voltage to show the direction. So we have the information to do the calculation for this case. We have B is given, which is B is 0.5 Tesla. Let me properly write 5 here. 0.5 Tesla. V is also given. V is 5 meter per second. And L is given as 1 meter length. So now we want to find the induced voltage, E in. So what is the magnitude of induced voltage, and also how about its direction? So direction, we already know the direction by using the left hand rule, right? Okay, so we do the calculation. E in using this formula is V cross B L. Since all of the component, which is E in, V and B is actually directed into the page. I just want to show that all of these components are perpendicular, meaning that at 90 degree. So we can just simplify this equation. So we just eliminate the cross product here to be VB sine 90 degree L cosine 0 degree in this case, because L direction is already the same as the direction of induced voltage. Okay, so becomes VB L, because sine 90 degree is 1. So from there we just can substitute the values. Is 5, B is 0.5, and L is 1 meter. Then finally we get the induced voltage of about 2.5 volt. Not only the magnitude, but we can write also the direction, which is the polarity, positive at the top of the wire. Positive at the top of the wire. Okay, so that's all for this question. Thank you.